this lesson, we are going to look at finding parallel and perpendicular lines, as we often want to find the equation of a line that is parallel to a given line or the equation of a line that is perpendicular to a given line. So let's just do a quick reminder here. If we have a line, I'm going to call it L1, that is equal to y equals m1x plus b. And let's suppose we have a second line here, L2, that's equal to y equal m2x plus b2. I'll call this b2 and this one b1. Now we know that if these two lines are parallel, then m1 equals m2. So here L1 is parallel to L2. And this symbol here, these two vertical lines, this is the symbol used when two lines are parallel. Now we also know that if we are given m1 and m2 is equal to negative 1 over m1, so that is the negative reciprocal of the slope of this line, that means that L1 is perpendicular to L2. So this is the symbol that we use to say that two lines are perpendicular. Okay? So when we are given a line and we want to find a line that is parallel or perpendicular, we can do that by looking at the slope of that line. Then we need a second point in order to find the y-intercept. So let's go ahead and look at some examples of that. So in this first example, we have the equation of a line y equal to 2x plus 3, and we want to find the equation of a line that is parallel and goes through the point 1, 7. So here we have L1, this is y equal to 2x plus 3. So our value for our slope here is 2. That means in our second line, y equals mx plus b, that this will have the same slope. It's parallel, so our slope will also be 2. Now, in order to find our value for our y-intercept, we need to take the value from this point and substitute it for x and y here, and then solve for b. And this will give us our y-intercept. So let's go ahead and do that. So here y is 7, so 7 is equal to 2 times our x value is 1 plus b, so 7 is equal to 2 plus b. Now let's subtract 2 from both sides. So that gives us b is equal to 7 minus 2, or 5. So we can take that value, put it into b here to give us y equals 2x plus 5. And that is the equation of a line parallel to y equals to 2x plus 3 that goes through this point. Now we're going to do the same thing, but we're going to find a line that is perpendicular. So again, our first line is y equal to 2x plus 3, and our slope is 2. So in our second line, we want a line that is perpendicular, and so our value for our slope will be the negative reciprocal of this first slope. So that will give us negative 1 over 2. So we can put that in here. So y is equal to negative 1/2 x plus b. And again, in order to find b, we're going to substitute the value at this point, negative 4, 3, into x and y in this equation, and then solve for b. So here our value for y is 3, so 3 is equal to negative 1/2 times negative 4 plus b. So let's simplify here. So we have negative 4 times 1/2, and that's going to give us positive 2. So 3 is equal to 2 plus b. Now let's subtract 2 from both sides to isolate b. So b is equal to 3 minus 2, or 1. So now we can put that into this equation. Y is equal to negative 1/2 x plus 1. And that is the equation of a line perpendicular that goes through the point negative 4, 3. Now in this example, we started with the equation of a line that is in slope-intercept form. So we had our value for our slope, but sometimes we don't have that. Sometimes we are given an equation in general form, such as this one here, 3x minus 2y minus 6 equals 0. So we're going to start by converting this into the form y equals mx plus b. So we want to first convert this line so that we have our slope easily. So let's go ahead and do that. So we are starting with 3x minus 2y minus 6 is equal to 0. And we need to isolate y on the left-hand side. So let's start by adding 6 to both sides. So we have 3x minus 2y, this cancels, is equal to 6. Now let's subtract 3x from both sides. So that gives us negative 2y is equal to negative 3x plus 6. Now we need y on its own, so if we divide by negative 2, that becomes 1y. And what we do to this value, we have to also do to each term on the right-hand side. So now we have, these are both negative, so that becomes positive 3 over 2x, and this becomes minus 3. So this is our equation in slope-intercept form. Now we can look at an equation that is parallel and an equation that is perpendicular. So I'm going to do this one in green here. I'm going to say L1 is y equal to 3 over 2x minus 3. And we want to find the equation of a line that is parallel to that and goes through the point 2, 4. So L2 here, y equal to mx plus b. And we know that our slope in our first equation is 3 over 2. So we can use that in here, and that gives us y is equal to 3 over 2x plus b. So let's take a look at this, and we're going to substitute the point 2, 4 into here for x and y. So y is 4 is equal to 3 over 2 times 2 plus b. And let's simplify, those cancel, so we have 4 is equal to 3 plus b, and let's subtract 3 from both sides, so that b is equal to 4 minus 3, or 1. So now the equation of our new line is y equal to 3 over 2x plus 1. And that's the equation of a line parallel that goes through the point 2, 4. Okay, let's do the same thing, but now we're going to look at a line that is perpendicular. So again, our first line here is y equal to 3 over 2x minus 3, and our slope is 3 over 2. So in our second line, y equals mx plus b, we want our slope to be the negative reciprocal. So that would mean our new slope is negative 2 over 3. So it's the reciprocal, and we've changed the sign to make it negative. So we can put that into here. So y is equal to negative 2 over 3x plus b. And again, we're going to substitute the point negative 3, 4 into y and x and solve for b. So our value for y is 4. 4 is equal to negative 2 over 3 times negative 3 plus b. And let's just cancel those. They're both negative, so this becomes positive. So 4 is equal to 2 plus b. And let's subtract 2 from both sides to give us b is equal to 2. So now the equation for our new line is y equal to negative 2 over 3x plus 2. And that is the equation of a line that is perpendicular and goes through the point negative 3, 4.